Hey everyone, today we are going to solve the Daily LeetCode challenge of 2nd April 2024 and the problem statement is isomorphic strings. So let us first understand the problem statement. So according to the problem statement, we have been given two strings S and T and we have to determine whether they are isomorphic or not. Now what does an isomorphic strings mean? If we can replace the characters of S so as to form it T, then we can say that these two strings are isomorphic. So let's take an example. So if we have something like egg and we have add, then we can see that this is the string S and this is the string T. Okay. So we can see that the first character of string T is A, whereas the first character of string S is E. So what we want to do is we want to replace this E with A in order to make it similar to T. Correct? Now we'll move forward. So we can see that we have a D in T, but we have a G in S. So what we'll do, we'll replace this G with D. So we'll get a D over here. Similarly, we can see that here what we have a D. So we'll replace this G with a D and we'll get add. So we can see that we have successfully converted this string S to string T, correct? Because string T was add and string S has now become add. How it has become add? By replacing the characters, right? By replacing the characters of S, we were successfully able to get string T. So we can call these two strings, that is egg and add, as isomorphic. Okay. But now before replacing the characters of S to the characters of T, we have to follow some certain conditions. And what are those conditions? These are the three conditions. Now let us look at each of the conditions individually. Okay. So the first condition is that all occurrences must be replaced. Okay. Now what does this mean? It means that, say for example, if I have a string as title and I have another string as paper. Okay. So this is our string S and this is our string T. Fine. So we can see that the first character of string T is P, whereas the first character of string S is T. So what we want to do is we want to replace this T with a P, correct? So as to make them equal. So if I replace this T with a P, then what I have to do is I have to replace all the occurrences of this T with a P. It means that if I have this T occurring in the string S anywhere, okay, then what I have to do, I have to replace all those T's with a P. So we can see that here also we have a T. So it means that this T will also get replaced by a P. Correct. So if we had some more T over here, so what would happen? This T will also have been replaced by a P. This would also have been replaced by a P. This would also have been replaced by a T. P. Correct. So it means that we have to replace all the occurrences. Correct. Now coming to the second condition. The second condition is that order must be preserved. Now what does it mean? It means that, say for example, if you have a string as egg and if you have a string as dad, okay, so you'll say that, okay, what I can do is I have a over here and I have a E over here and both of them are occurring only once. So what I can do is I can replace this E with a. And since this G is occurring two times and this D is occurring two times, so what I can do is I can replace both these G with two Ds. So what I'll get? I'll get ADD. And what we can do, we can rearrange it to get DAD. Correct. And you'll say that, okay, these two are isomorphic, but this is wrong. Why? It's because we cannot rearrange these characters. We can only replace the character. Correct. We can't rearrange the character. That is, we must preserve their original order. Fine. Now coming to the third condition. And this third condition is one of the most important condition. It states that two characters should not be mapped to the same character. Let's see what does it mean. So if we have a string S as BADC and if we have string T as BABA, okay, so we are present at the first element. So you'll say that, okay, we have B at the beginning of this string T and we have B at the beginning of string S. So what does it mean? It means that we have to map this B of string S to the B of string T, correct? So what we have done is we have mapped this B to B, correct? That means that this B got replaced by B only, correct? Now we'll move forward, okay? So we'll see that, okay, we have a over here in string T and we have a over here in string S as well. So what we have to do is we have to replace this A with A only, correct? So what we have done is we have replaced A with A only. That is, A got mapped to A only, correct? What does this mapping represent? This mapping represent that which character got replaced by which character, correct? That is, we replace this A with A only. That's why we are mapping A to A, correct? Now we'll move forward. So we'll see that we have a B over here, but we have a D over here. So what we can do is we can replace this D with B, correct? So what we did, we replaced this D with B, correct? And then we'll move forward. Then we'll say that we have a A over here and we have a C over here. So what we can do, we can replace this C with a A. So what we did, we replaced this C with a A. And after that, you'll say that, okay, we were successfully able to get the string T by replacing the character of S. But it's wrong. Why? So we can notice one thing. That is, here we are mapping B to B. And here we are mapping D to B. So what does it mean? It means that firstly we are mapping D to B and then we are mapping D to B. That is, two characters are getting mapped to the same character B, which is wrong because it's clearly mentioned that two characters can't be mapped to the same character. Additionally, here we are mapping A to A and here again we are mapping C to A. So we can't do this. We can't map two characters to the same character, right? So it's wrong. So have to keep in mind that we are following the third case while solving this problem, okay? So I hope all these three conditions are clear. So let's see how we can solve this problem. Let us consider this one as string S and this one as string T. Now we know one thing. What is it? We know one thing, that we need to maintain a hash map. Let's say this hash map is M1. Okay, as of now, let's take its name as M1. So we need to maintain a hash map. Why? It's because we need to keep track of the thing that which character had got mapped to which character, right? So in order to keep a track of this, that which character we are mapping to which character, that is which character got replaced by which character. So for that purpose, we will be maintaining a hash map, correct? So let's see what we'll do is we are present at the first element of both these strings, okay? So we can see that in this string T, we have a B and in the string S as well, we have a B. So what we can do, we can replace this B with B only. So what we did, we mapped B to B, that is we replaced this B with B, correct? Now we'll move forward. So what we can see that in T we have a and in S as well we have a. So what we can do, we can replace this A with A only. So what we did, we replaced A with A. So we'll map A to A, correct? Now we'll move forward. Now what we can do is, we will see that we have a B over here, but we have a D over here. So what we can do is, we can replace this D with a B. So what we did, we replaced D with a B, correct? And after that, what we'll do, we'll move forward. And we can see that what we are doing, we are having a over here, we are having a C over here. So what we'll do, we'll replace this C with the A. So what we did, we replaced with C with the A and we'll say that, okay, we were successfully able to convert S into T by replacing its character. But your answer is wrong. Why? Because we can clearly see that this B is getting mapped to B and this D is also getting mapped to B. That is, we are violating the third condition. That is, the two characters can't map to the same character. But we are mapping two different characters, that is B and D, to the same character B. Similarly, here as well, we are mapping two different characters. That is, we are mapping A and C to the same character A. So it means that our answer is wrong. So what does it mean? It means that only one hash map is not sufficient enough in order to solve this problem, because we want to keep track of the other part as well. What do I mean by other part? We also need to maintain another map M2 in which we will store that which particular character replaced which character, correct? Because here what we were storing, we were storing that this character got replaced to which character, correct? And here we will store that this character was replaced by which character. That is, if I'll be storing DB over here, so it means that D got replaced by B. And what I'll store over here, I'll store BD. So it means that this B is a replacement of this D, correct? So in M1, what we were storing the replaced character. That is, this D was the replaced character. And corresponding to it, we were storing its replacement, correct? That which character we stored instead of this D, correct? And here what we are storing in M2, we will be storing the opposite. That is, we will be storing the replacement and its corresponding replaced character, correct? Replaced character. So let's do the dry run on the same test case by maintaining two hash maps. Okay, both M1 and M2 would be empty and we are present at the first character of both the strings. Okay, so we will firstly check, is this B present in our hash map? So B is not present in our hash map. So what does it mean? It means that we have not yet replaced this B with any other character, correct? So what we'll do, we'll replace this B with a B because we have B in T, correct? So we'll replace this with a B and we'll store that B got replaced by the character B. Okay. And in M2, we will store that B was the character which is the replacement of this B in S. Correct. Then we'll move our pointer forward. Fine. Now we will see that we are having a A over here and we are having a A over here. So what we'll do, we'll replace this A with A only. So we'll get A and its corresponding replacement as A, correct? Now what we will store over here, we will store that this particular A was formed by replacing this A, correct? Now we'll move forward. So we can see that we are having a D over here. So we'll check, is this D present in our hash map? So we can see that this D is not present in our M1. So what does it mean? It means that till now we have not replaced D with any other character. Okay. And now we'll check that is this B present in our M2? So we can see that this B is present in our M2. So what does it mean? It means that B should be replaced with B only. Correct. But here what we are having, here we are having D. So what we'll do, we'll replace this D with a B. So what we'll store D and B, correct? But we can see over here clearly that B is already replaced by B, correct? So it means that we cannot replace D with a B, correct? Because if we replace D with a B, then we'll violate the third case. That is, we are mapping two characters to the same character B, correct? So the moment we'll get that this B is already mapped to a B, we'll simply return false because this D cannot be mapped with a B, correct? So I hope it's clear. Now let's quickly do the dry run for this test case. So initially both M1 and M2 are empty and these are the two string. That is, this is S and this is T. So basically in M1 what we are storing, we are mapping that which character of S got mapped to which character of T. And in M2, we are storing that which character of T got mapped to which character of S, correct? And I hope it's clear that why are we using the second map? Because we don't want to violate the third case, right? That is, we don't want the two characters to be mapped to the same character, correct? So let's start the dry run. So we are having a T over here. So we'll check, is this T present in our hash map? So we don't have T in our M1, correct? So what we'll do, we will store this T and corresponding to it, we will store this P. That is, we have replaced this T with a P and we'll replace T with a P. Okay. And now we'll check, is this P present in our M2? So P is not present in our M2. So what we'll store, we will store P and corresponding to P, we will store a T. So it means that P got mapped to P. Correct? Now what we'll do, we'll move forward. Now we'll check, is this I present in our M1? So we can see that I is not present in our M1. So what we'll do, we will replace this I with the A. And here we will check, is this A present in our M2? So A is not present in our M2. So what we'll do, we will store A and corresponding to it, we will store a I. So it means that I was replaced by A over here. And here it means that we are mapping I to A, correct? So here we are just storing the opposite of this, correct? Now what we will do? Now we will move forward. So we can see that we have a T. Now we'll check, is this T present in our hash map? So T is present in our hash map. Now the moment we'll find out that this T is present in our hash map, what we want to ensure? We want to ensure that corresponding to this T should be P in the string T. Why? Because we discussed the first case that if I replace this T with a P, then all the occurrences of T will be replaced by P only, correct? So in order to be S and T isomorphic, here it should be P, correct? Then only we will be able to replace this T with a P. So we will check that, is this P? So here it is P and corresponding to this T is P only. So what we'll do, we'll replace this T with a P. Additionally, what we did over here, we replaced this I with a, correct? We replaced I with a. Fine. Now what we will do? We'll move forward. So we are present over here. Now we'll check, is this L present in the M1? So L is not present in M1. So what does it mean? It means that this character L of S was not mapped to any character of T, correct? So what we'll do, we will map this L to the character E. So it means that L would be replaced by E. So we replaced L with a E. Fine. Now here we'll check, is this E present in our hash map? That is in M2. So E is not present in M2. So what does it mean? It means that this character is not mapped to any of the character of S, correct? So what we'll do, we'll store E and corresponding to it, we'll store this L. Fine. Now we'll move forward. So now we are present at this E. Now we'll check, is this E present in our M1? So E is not present in M1. So what does it mean? It means that earlier we didn't encounter this E and this E wasn't replaced by any of the character, correct? It means it's not mapped to any of the character. So what we'll do, we'll replace this E with this R. So we'll replace this E with R, correct? So we have done this mapping. Now we'll check, is this R present in our hash map? So this R is not present in M2. So what does it mean? It means that this R was not mapped to any of the character of S. So what we'll do, we'll simply store R and we'll store E corresponding to it. Now we'll move our pointer forward. Now we can see that we have clearly processed all the characters of string S and T, and we have not got any invalid cases, correct? So it means that both of these strings are isomorphic, correct? And will simply return a true. Fine. Now, I hope it's clear to you all. So let's quickly code this. So we will create two unordered map of character, comma character type. Let's call it as M1, and let's call the another hash map as M2. Now, what we will store in this M1, we will store that which character of S is mapped to which character of T. And in M2, we will store that which character of T is mapped to which character of S, correct? And why are we using this? We are using the first hash map in order to keep track of that which character was mapped to which character, right? That is which character got replaced by which character. And what is the need of this M2? We are using this M2 in order to make sure that this third condition is not violated. That is, two characters are not mapped to the same character, right? So for that reason, we are maintaining the second map. So now what we'll do? Now we'll simply iterate over both the strings. So index equals to 0, index less than s dot size. And it's clearly mentioned in the problem statement that the size of both the strings are equal, correct? Now what we'll check? We'll check that if the current character is present in M1 or not, correct? So if we have that the current character of S is present in M1, then what we should have? We should also have that the current character of M1 should be mapped to the current character of T, correct? And if it is not mapped to the current character of T, then what we'll do? We'll simply return a false over here, correct? And we'll say that if we have M2 and the current character of M2 is already present in the hash map, then what does it mean? It means that the current character of the string T, if it is not mapped to the current character of string S, then what we'll do? We'll return a false, correct? Otherwise, what we'll do? Otherwise, we'll simply add the current character of T to corresponding to the current character of S in M1. And similarly, we will add the current character of S corresponding to the current character of T in M2. Fine. Now, finally, we'll return a true. Now, let's see this. What does it mean? This means that if our current character of S is present in this M1, correct? It means that, let's take this example. It means that if this E is present in our hash map, correct? Then what do we want to check? We want to check that the value that we have stored corresponding to the current character of S should be same as the current character of T. Why? Because we said that if we are replacing a T with a P, correct? So it means that all the occurrences of T should be replaced by P only, correct? Like we saw over here, right? If we are replacing this T with a P, then all the T that we'll find, we have to replace it with P only, correct? So as to ensure that, we are checking this, that if the corresponding value of the current character is not same as the value present at the index of the Tth string, then it means that it's not isomorphic. So we are returning false. And the same is the reason for this one as well, correct? So let's quickly run this. So we are getting a correct answer. Let's submit it. And it got accepted. Talking about the time complexity and space complexity. So if we consider n as the size of the string S or n as the size of the string T, then the total time complexity would be order of n. Why? Because here we can see that what we are doing, we are completely iterating over the characters present in S and T, right? And both S and T will contain only n characters. So it means that we are iterating over n characters. So therefore, the time complexity is order of n. And what is the space complexity? Here we can see that we are using two maps, M1 and M2. And in the worst case, what could be possible? That all the characters of string S are distinct and all the characters of string T are distinct as well. So what we'll have? We will have a total of n entries in M1 and we'll have a total of n entries in M2. So it will make us a space complexity of order of 2n. Since 2 is the constant, so we can ignore it and we'll get a time space complexity of order of n only. Correct? So that's all about today's daily LeetCode challenge. Thank you.